Okay, well, first of all, thank you everyone for joining. I think we'll kind of start now. There's at least one person on this call, no, two people have my number to contact me by WhatsApp. So if you can't hear me and I'm just waving like a madman, then please tell me now. So feel free to let me know that. Just so everyone's aware, this meeting is being recorded. There's a question and answer session at the end. So either put your questions into the Q&A section here at the top or the chat function, whichever works for you. Most of us are all fairly used to using Teams these days. But apart from that, yes, we'll press on. So I'll just share my screen. No one sent me any weird WhatsApp saying, I can see your mouth moving. So I assume we're all good to go. Okay. So just bear with me. My laptop is being a bit slow. So hopefully everybody can see that first screen. I'm sure that David will tell me if he can't. Okay, so like I say, thank you all for attending. Just a very, it's going to take probably about an hour or so. So hopefully it certainly shouldn't take any longer than that. Most of you, I'm assuming, have got the email from SciMed about the ICP-OES, so you know who we are. So the agenda is very simple. It's a quick introduction to basically who Analytik Jena are. I know some people on this call are aware of Analytik Jena. Some people won't be as aware of them. So a quick literally 3 or 4 slides on who they are. I'm going to give you a quick overview of the new PQ9200 ICP-OES, talk about some of the key features, etc., how it differs from the 9100 and even the 9000, its predecessors. They're going to hand over to David. Dave's going to go through some sort of real life applications, actually show you where these features are being used and where they're going to benefit you going forward. And then we come back and have a sort of a question and answer session. So I hope that fits for everybody. Like I say, take about 60 minutes, hopefully no longer than that. Okay, so moving on. Actually, the first slide is about us. For those that don't know us, we are a distributor. We're not the manufacturer. In this case, of course, it's Analytik Jena. SciMed deal with about 30 odd distributors worldwide. These are some of them, not quite all of them. Of course, that map is constantly changing. You can see mostly in Europe or North America. There are a few in the Far East as well. But we cover everything from AA all the way through to XRF. Do lots of different techniques, unless it's chromatography. But yeah, if you've heard of any of these companies before on your left, but things like particle sizers, polarimeters, XRF, supercritical fluids, oil condition monitoring, scanning electron microscopy, things like that. So yeah, most of my colleagues deal with those. I tend to deal on the elemental analysis and mainly with Analytik Jena. But yeah, it just gives you an overview of who we are. We do post lots of things on LinkedIn. Our marketing manager is very keen on that. But if you don't already follow us on LinkedIn or maybe on YouTube, we do put videos on YouTube and what have you, then please keep an eye on these things for events that we're running on a fairly regular basis. So Analytik Jena. So like I say, I'm aware that not all of you know who Analytik Jena are. So just a few slides on those guys. So as it says, at a glance, they're headquartered in Jena, which is old East Germany. So the company in its current format has existed since about 1990, but it's actually been around for over 100 years now. They're set up to deal with distributors like ourselves. As it says there, 86% of their business is through export. They're present in over 100 different countries. They have direct organisations. There's actually an Analytik Jena UK. They bought a small spin-out company from Imperial College. It's all to do with life science. About 70% of their business is chemical analysis, the products that we deal with, but there's some of their business that's also life science as well. You can see one of those in the bottom left, some sort of liquid handler or something. So they have a few affiliated companies that do that, and a few companies in both the US, but also behind the Iron Curtain. There are about 1,000 people, and they're part of a much bigger group called Endress and Hauser. Like I said, they're set up to deal with distributors like ourselves. Every company has a mission statement, has a value. The reason I put this up there is just that first line. The people who create and use our products are the real drivers of change. I would say that most Analytik Jena's products are a bit different. They're not me too products, and hopefully you'll see that with the OES as well. But they do try to be different, so they are driving change within the analytical industry. I think that is a fairly true statement, to be fair. And this is an overview of what they do from a chemical analysis point of view. So they do sample preparation, handling, I think that microwaves. We don't actually sell their microwave, we choose to sell somebody else's. They do microwave digestion, AAS, ICP-OES, ICP-MS, dedicated mercury analyzers, some combustion analysis for people doing carbon, sulfur, nitrogen, chlorines, and even the halides in general, total organic carbon, total nitrogen analysis, as well as UV-Vis, which is used for standard UV-Vis spectroscopy, as well as dissolution models as well. So there's a fairly broad range of chemical analysis products. But moving on, I guess, to the most important part of this presentation, the Plasma Quant PQ 9200 series. That's it. You've all seen pictures of it in various emails and LinkedIn posts, but that's what it looks like. That is a real working system. It's not just a mock-up, but that's it. We'll go through some features of that as well. So, as it says in the top left, the aim of designed this, it is about sort of analytical excellence. So it's trying to be the best instrument, the most excellent instrument on the market for getting people's results. Some key things that help with that are the resolution. It's a high resolution system, so it has a resolution of 2 picometers around the 200 nanometer range. Go up to 400 picometers, it's about 400 nanometers, it's about 6 picometers. But obviously a lot of wavelengths we're measuring are within that sort of 200 nanometer window. So the resolution there is very, very, very small, 2 picometers. Other systems on the market typically around about 6 to 8. This means we have simple things like just detection limits are just the best. It's as simple as that. They're just very, very low detection limits, great RSDs, has a huge working range from 160 nanometers up to 900. So we can measure things like chlorine up at, I think it's 894, and measure things like some of the halogens. Is it bromine? I think it's down to 163 and things like that. So it's a very, very wide working range to help deliver those excellent analytical results. Bit of a cheesy photo there of one of our colleagues over in Germany, but trying to give the impression that it is, as they say, a space-saving powerhouse. It is 40% smaller than the previous system, so it really is a very small system. It's very, very fast to warm up and start. It's designed to be turned off and on. It's powered off and on, and you're running within 10 minutes. And again, a wide working range. The plasma powers from 700 up to 1700 watts. So it's small, but it's robust and very, very powerful as well. There's a few things I'm mainly going to skip on to in the next slides, really, but some of the features are things like the V-shuttle talk to dual view plus and the plasma check with the camera. Just to make it more reliable, more simple, more flexible. So I guess one of the big things with the new system, as I said, is the size. Some of you have got that system on the left-hand side. Compared to old ICP-OESs that we all remember, it's still a lot smaller, but it's a fairly chunky system. The new one, as you can see, is only 600 mil wide and just over 800 mil deep. Part of that, or the main reason for that actually, is to do the generator. They've also, which I'll move on to in a moment, they've also done some work on the optics. But it's much, much smaller, say about 40% smaller in terms of the footprint. But actually, it can go even smaller than that. That tray that you see at the bottom right, where it says 600 mil, can be removed. You could put things like a humidifier there, an ultrasonic nebulizer, the hydride kit, whether you want to put an auto sampler even, put that at the front, and that reduces the depth. So it's 600, the actual footprint is 600 by 600 mil by 570 mil. So a very, very small footprint indeed. So taking up less bench space, and as we all know, bench space is just critical these days. Most labs are getting smaller and smaller, but trying to get more and more kit in there. So yes, a much, much smaller system than previously. Something else that's new, they do a range of salt kits, HF kits, organic kits, which obviously come with various torches, spray chambers, nebulizers, etc., etc. Everybody offers those, we know that. But one they've launched specifically with the 9200, you can put it on the 9100 as well. It's this precision kit. So if you look at the bottom left, that's just like a close-up photo of the end of what they call the precision nebulizer. Don't ask me how it works, please. All I know is it reduces the LODs and the LOQs by a considerable margin, and also improves your RSDs. So people that are looking to push that envelope, that are trying to get down to much lower levels. Most of the LODs on this system are in the parts per trillion range, so it's very sensitive. But if you're really trying to push what you've got at the moment, this can help you improve your results analytically in terms of precision, but also in terms of the LODs as well. But this is new. This precision nebulizer is new. Like I say, the older systems can also use it as well. So the four main features, which I'm going to talk about a little bit and then hand over to Dave, who's going to show you where they're actually used in the real world, are the high resolution optics, the generator, the high frequency generator, the dual view plus radial view, observation views, and then the V-shuttle torch. And a lot of these have been carried over from the previous system because that works so well. But as it says, what we're hoping is that the 9200 Elites basically eliminates all those analytical shortcomings that we had to deal with in the past with ICP-OES analysis. This helps overcome them and make your results better. So the V-shuttle torch, in some respects, it's very simple. It's a torch. So what do we expect it to do? Well, we have to take these things apart. So it's very easy. It's a demountable torch. So it's very easy to take off the system. It's just the body there on the left here. I hope you can just see my mouse moving around it. Just sits on a rail, which just literally goes up and down. Take it off with one hand. Very simple indeed. Slide that off. Demountable torch. Clean all the bits individually. You can then mix and match if you need to. You can have ceramic and quartz. So maybe ceramic inner tube and quartz outer tubes, depending on your application. You don't have to go fully ceramic. Reassemble it, slide it back on that rail. It fits. It's chemically resistant, thermally resistant. There's no fixtures or fittings as such. There's just flanges that clip into place, and your gases are good to go. There's no sort of realigning. It goes back into the same place. So very robust, very simple to clean, very simple to take apart. Just makes your life easier. This is new. So the generator, so I'm going to try something here. So you can just see that is actually the plasma running there on the right hand side there. I think that's a 15% sodium chloride solution. It's a new generator. The older system uses a 40 megahertz generator. This uses a 27 megahertz solid state generator, which has actually been in the ICP-MSs that Analytik Jena have been manufacturing for several years now. So they've basically moved it over from the ICP-MS to the ICP-OES. So it's fully designed and made locally in Germany. It's very good in terms of this instant power matching, so it can cope with dirty samples being thrown at it or dirty matrices. This with high plasma, you don't get collapse or plasma extinguishing. You could argue the design there with the 4 coils, yeah, a little bit traditional, a little bit old-fashioned, but it's that robustness. So the ability to run, as it says at the bottom, saline solutions, 300 grams per litre. You can run alcohols and naphtha through it completely neat. It handles those because of that power transfer very well. And it has this very wide working range, let's say from 700 to 1700 watts. But that generator has again helped with the footprint. It's much smaller and also has some other benefits I'll mention in a moment. So as I said, it can handle the extreme matrices. It warms up very quickly. The instrument is designed to be powered off, as I said earlier, so it's not using any argon, any electricity at all. You're ready to go within 10 minutes. As you'd expect, the gas box is fully automated. All the gas flows are set by the software. You can use oxygen. A lot of people don't these days, I know that, but you can. You've got lots of sort of organics in there. Lots of sensors in the event that something gets blocked or something's not working properly, shuts the system down. But the big thing about that generator is the argon usage. So it uses about 30% less argon than the previous system. Most applications are around about 10 to 11 litres total argon. That's everything. That's including even the recycled argon that we use to remove the end of the cone. So your total argon consumption in the region of 10 to 11 litres per minute. Previous system was probably about 14 to 15, depending on the application. It's also a reduction, again, it's about 30% actually for the power consumption. The generator doesn't need as much power, so it's cheaper to run, cheaper to cool. There's going to be a new chiller that comes with this, which is a bit more environmentally friendly. It's not as power hungry, etc. So it's cheaper to run than the predecessors. And there's an integrated camera for monitoring the plasma, which can be useful for Obviously, when you're doing method development, make sure everything's working properly. But again, it could be that the piece is not next to the system. You can see it on the software, so you just keep an eye on it if you need to. So yeah, so the generator is new. It does bring quite a lot of benefits to the system, cost savings, etc., etc. The high resolution optics, yes, they've been tweaked, but fundamentally very similar to before. And I'm saying about this being a specialized sort of system aimed at, where they want to drive change, and that's where the high resolution optics come in. So it has this resolution of 2 picometers for the Elite model. There is a standard system, just PQ 9200. It's about 6 picometers. We don't tend to sell that in the UK. That's more focused in the Far Eastern market. In the UK and Europe, people just tend to be interested in the Elite model because it brings something different. But it's this very, very sort of this fantastic resolution of 2 picometers. It's very fast. You can simultaneous background correction. You've got access to 40-odd thousand lines. Continuously looking at that wavelength range, so 160 to 900 nanometers, which gives you very low integration times, very low detection limits. Obviously, it's multi-elemental. It's an ICP-OES. Dave's going to talk a little bit later about the ABC, the automatic baseline fit, which again is about getting the results correct in the first instance, making your life easier. There are interference removal tools. Sometimes you have direct overlaps. We know that. Even the high resolution can't fully resolve those. So it's a very simple tool, which again, Dave's going to explain in a bit more detail. But it's this combination of the CCD detector with the optical design, which has a 10-year warranty. The optical bench is a 10-year warranty, which means you just get the best data first time around without worrying about any sort of spectral interferences, etc., etc. And then there's the plasma views, what they call dual view plus. So yes, everyone has axial radial, we know that. Looking at low levels for axial, high levels for radial, but you can basically attenuate the detector. I personally would query the usefulness of having axial plus, because it overlaps the axial and the radial, and to switch from one of those modes to the other takes a couple of seconds. So to me, and what we see people using, is the axial radial and the radial plus modes. It just extends that working dynamic range. So you can work, sort of part per trillion level up to percentage levels in one run, and it's just, let's say, a couple of seconds to switch from one view to the other. Obviously, there's no hardware changes, very simple to do with the software. And we have this, what they call this counter gas, this argon neutral counter gas technology. So basically, any argon gas that isn't used, it's just recycled to the end of the cone to remove that sort of turbulent area of the cone, the plasma cone, removes that tail. So we don't have thermal breaks. We don't use additional argon. We don't have to have compressors that need to do that as well. I know everyone does it differently, and everyone will argue that theirs is the best. But where ours is really good it's just its efficiency. So it's cutting down that argon usage more than anything else. And also because the way the argon goes through the system, you get great transparent, great readings in the UV range as well, because you're purging the optics at pretty much the same time. That is a quick overview of those 4 main features: the V-shuttle, the generator, the high resolution optics, and then the dual view plus. I'm going to hand over to David now. He's just going to use some of those and show you some real world examples of those and show you some actual data. So I'm just going to stop sharing my screen, and then you can start sharing yours, David, and then you'll come back to me towards the end. Okay.
Right, just started sharing my screen there. Hopefully it will come up in a minute. Right. So, as Matt said, I'm the applications specialist here at SciMed, and so I deal with all parts of the Analytik Jena range: ICP-MS, AAS, and in this case the ICP-OES, and a little bit on a few other manufacturers as well. So what I'm going to talk about is give an overview of what's really, really good about this ICP-OES. So just to recap a little of what Matt says, the advantages here is we have really high resolution and we have really high sensitivity. And obviously over the last few years, I've got to get to know the 9100 version very, very well. And it's a really good instrument. It's very excellent for a number of applications for our customers. But now the 9200 has even improvements on that, not just the compact design, improved performance. It does everything the 9100 did, but now also we have this lower energy and argon consumption. Now, I'm going to start off by looking at just the sort of headline limits of detection that Analytik Jena say. Obviously, these will be done under very favourable conditions. So these are the excellent sort of the best LODs that you can achieve. And you know, using axial view, we can get some really amazing limits of detections for things like cadmium. We can even do chlorine at very, very high wavelengths, and across the board, just excellent limits of detection. But they're more the headline ones. I'm going to more focus on some real world applications. So the defining difference really, as well as the very high sensitivity, these two things are linked, the high sensitivity and the high resolution. And the standard example Analytik Jena like to do is how with a more standard resolution, in the presence of high arsenic, this cadmium line, which is a very nice cadmium line to measure, is not fully resolved. And so getting the high resolution gives us the raw data. It doesn't need any mathematical processing afterwards. And so we can resolve these peaks, get very good half bits. We can measure right on the peak center. Another good example is lead in the presence of aluminium or molybdenum. And again here, the high resolution can create a much bigger increase in the sensitivity of the peaks simply by focuses in and removing the neighbouring interferences. So you can hear for lead with aluminium or with molybdenum and lead there again. So similar again, but this time we're not comparing with the other system. We can resolve selenium from chromium at the same levels very, very nicely and very easily. Just using in this case, the standard kit on the Elite system. And a good advantage of this, you can use the automatic background correction for a more accurate setting of the baseline. So it doesn't just look at a small area, and it produces a very, very accurate baseline. So as well as quantifying our analytes very accurately, it also quantifies the interfering elements, the matrix elements, lines very easily. So in that way, our background correction is much better. There are, of course, some lines we'd like to look at in some extreme matrices, for example, selenium in manganese metal, and even the high resolution we have can't fully separate that interference. It's only 1 picometers away, as you can see in the top right. What we can do, however, is access at this point other lines which are not interfered, but still again on a lower resolution system wouldn't have access. So we've got, in the case of selenium, we can go to a couple of lines which would not traditionally be measured and still achieve excellent LODs and excellent precision. So if we can't, so obviously it's always best to actually do this interference removal physically or in reality. Sometimes, of course, that is still not possible. So the resolution here is sufficient to remove the boron peak. This is boron traces in steel. Obviously, boron's important in steel making. And we can remove it from the 249782 peak with just by resolution for quite easily. Actually, it's a reasonably big gap. But we can't remove it from the 249772 here. So it's too close. Now, in this case, we do have the option of running a matrix solution. We only have to run one matrix solution at one level, and then that can be saved for all future analysis. So basically, we're running the iron with no boron, and the algorithm will take that out. And it only needs to be done once, and it's always fitted, and it's performed automatically, as it might say. Another example of that, if our steel has molybdenum in it, we can look at a different boron line, and again, it's the sort of three-pronged approach, really. High resolution, high sensitivity, the automatic baseline, and then the CSI modeling. But that's perhaps enough for now about interferences. There's lots and lots of other good examples and where it's very beneficial in a lot of applications. But now I'm going to sort of move on from the high resolution really to look at the robustness of the plasma. Obviously, at the moment, there's a lot of interest in measuring brines, in particular in the lithium industry, and we have a couple of instruments out there with companies producing lithium. And this is a really nice example of how we can receive great limits of detection in real samples. Now, so this table first tells the LQ, so we're talking the limit of quantification, 10 times the standard deviation, 3 times higher than the limit of detection, and very excellent in when we're just looking at 1% HNO3. This is measured with the salt kit, so a sea spray nebulizer, some ceramic tubes to just decrease the wear, and an argon humidifier as well to stop the salt evaporation. But if we move up to sort of real world samples and really quite salty ones, so from 1% HNO3 to 35 grams per litre brine, which is roughly around seawater, the LODs really haven't changed very much. And again, even if we go up to 100 grams per litre or 10%, really not changed. And in fact, manganese here didn't change at all. So it really shows just the robustness of the plasma. And obviously, as you go to more matrix, you would expect more interfering lines, and the high resolution can deal with that. This was a interesting little setup of the system for actually online analysis of lithium in even more heavy brine, say 250 micrograms. So what this was done was the salt kit, the humidifier, but also the Cetac AXS Plus, as that cuts down the amount going into the sample anyway. In this case, it was just measuring lithium sampling every 30 seconds. Also, with the T connector on the ASX Plus, you can get automatic dilution. And so in this slide, we can see that the precision of the measurements was excellent, considering this thing is working online, which is so a very different scenario to simply working things in the lab. And again, excellent precision, very low LODs. And one aspect, sort of little interesting quirk here, is with the high resolution, you can actually see that we have a double peak for lithium 7 and lithium 6. So to get an accurate quantification, we measure over a wider window rather than a similar point. But it also gives us some information about isotopic composition. Nice little quirk. Again, this is mercury, once again in the brines, and to show a couple of points really. Yes, we can still get great LODs in the brine. Also, we still get great LODs for mercury in general using this system, even without recourse to a hydride kit. Now, obviously, if you do put a hydride kit on the front here, you really get quite incredible sensitivity. But I think that's quite well known, so we won't go into that in further detail here. So once again, another thing looking at iron chloride, which is also quite a nasty matrix, and we can easily measure iron and cobalt and zinc and separate those. Also with lead in iron chloride, and again, to repeat, using the CSI software and the high resolution to move out very interesting interferences. So, moving on to a application of grape must. Now, grape must, perhaps not a well-known term, it is the freshly pressed grapes, so what is about to be fermented. And the feature that this shows most nicely is the use of axial, radial, and radial plus. As Matt said earlier, they seem to be the more commonly one used, and it demonstrates the capability to measure some very, very low concentrations of elements, such as cadmium, which obviously you don't want in there, but also simultaneously measure very, very high levels of things like potassium and magnesium here. And that is where the radial plus system is extremely useful, because it just extends that wine up. And so in this case, the wine is not digested, it's not diluted, it's measured directly just as wine. So this shows that, say, the calibration standards were adjusted to the ethanol level in wine. And once again, say, to repeat again a little, we just get excellent sensitivity, we get excellent resolution, so we can measure undiluted samples, we can measure nasty things extremely, extremely well. We can also move on to pure alcohols here. The main point of this slide is to show that with alcohols, with volatile stuff, we can attach the Peltier cooled spray chamber here, so now direct introduction of 100% ethanol. Similarly, for organics, we can look at undiluted or organic samples, and this now is using the organics kit, so which is more for tubing, and again the cooled one. And so you can see once again amazing limits of detection, great linearity of calibration curves, even in just a 10 times dilution of raw oils. So obviously that is very, very time saving. So the direct analysis of organics is a really, really strong point on this instrument. Once again, just to say, we can look at sulfur and accurately resolve that from its interferences. This was done using the Cetac oils auto sampler, so just to make the point that it's fully compatible with the full range of these. So just to go back to the start and summarize, it's got a lot of real points. It also makes quite a mean cup of coffee if you let it, not seriously. And with that, I'm going to hand back to Matt.
Okay, thank you, David. So just go back to that presentation again. I notice we've already got some questions in the Q&A. I'll tell you now in advance, Mark, I'm not sure. So I'll have to look into that one. But yeah, but I say we've already got some questions, so thanks those guys. So, okay, so just to pick up where David was, so I say hopefully some examples there of sort of some real world applications that some of you guys might be doing at the minute or looking to in the future, and be able to give you an idea of where this system can benefit. And I know some of you are doing this sort of thing already. So just press the joys of modern technology. So just a couple other things just to pick up on before we sort of get to the Q&A section. Along with the hardware, there's a new version of software. So it's now 1.4.0. What's changed? It's a lot of things behind the scenes, I guess. What we're seeing is more and more people are, if not using 21 CFR Part 11, which obviously come out of the pharmaceutical industry, which is all about sort of data integrity and sort of audit trails or what have you, more and more people want those features in their standard software. So from a 21 CFR Part 11, there's been some changes. You can now have, as it says there, customizable user levels and rights. It used to be that there's basically, I think, 4 fixed user levels. There's now up to about 9. You can adjust it and sort of make it more relevant for the people using the system. You have this active directory integration. It used to be connected to that local management level before. There's now an automated user logout if it's left unattended for a period of time. It used to be you had to put that in as a manual sort of default after X amount of time, please log me out. And the audit trail is just more detailed. It's also easy to read. And more useful for people, I guess, certainly for auditors that are coming in and looking at what you're doing. So a lot of those are now moving over to the standard software, because obviously people don't use 21 CFR unless they have to. So a lot of things like the audit trails have also been beefed up and improved. The user levels have been improved in the standard software as well. But there's some other things like it automatically sorts the absorption lines. So is that a big deal? Maybe, maybe not. What it does mean is your overall runtime is about 10% faster. If it saves you time, saves you money, it's not a bad thing. There are some other, certainly some calibration features. You can now choose. I've got to say, I would query this. You're all the analysts. You would know this better than me. But certainly when you're looking at things like LOD calculations, you can now be a bit more flexible. You can decide the number of replicates and which factors are there to use. And so that can have an impact on things like your R-squared values and things like your detection limits. If you have multi-element solutions, you can now be a bit more flexible in terms of which elements to actually measure and in which order to measure. There's a bit more flexibility on the standard lines within a multi-element solution. You don't have to measure them all, whereas previously you kind of had to. If it was in the method, now you can just click ones that you don't want anymore. So that's 1.4.0. Certainly the 9100 will work with the standard, with the new version of the software. If people want to see it, we can show that to them at a later date. We've got it on a laptop, so you can see the differences between it. I'm not sure that anybody on this call has a PQ9000. I don't think they do. I'm not sure if it goes all the way back to the PQ9000. Certainly 9100, the new software, it's a bit more slick, it's a bit more easy to use, but it's definitely got some things that were helpful from a compliance point of view. So just worth pointing those out. Some of you will recognize these pictures. There are various Cetac accessories, the AS Express for sort of flow injection for people with high matrices or looking just to reduce the runtime. You then got the SimPrep, the SDX for various sort of online and offline diluters. Then on the right hand side is the dedicated oil diluter that David showed in his application. So it's just to point out that the PQ9200 will support all of the Cetac product range. Analytik Jena do their own auto sampler. However, I would say this to anybody: don't buy it unless there's a really good reason. And the simple reason is the ASX 560 has a bigger capacity and is cheaper and has more options in terms of upgrades for dilution and flow injection, sample switching, etc. So I would always point people to the Cetac. And interestingly enough, it didn't used to be that the ASX 280 was usable on the Analytik Jena product range. That is now usable on all of them now. They've changed some things in the software that allows to work with that. But yeah, there's full compatibility with the Cetac product range, as well as they do their own as well. But I would always lean towards Cetac. because let's say more flexible and cheaper. So I guess just to summarize, really, the new PQ9200 is smaller, so it's saving space. It's more economical to run, saves money. Most people like that. It's more sensitive for some wavelengths. It's more accurate. We believe it's certainly more sensitive and accurate than other ICP-OESs out there. But it means you get the right results for time. So there's less post analysis manipulation of software. So that's, again, saving you time and money. We believe it's more robust. Certainly with the new generator, it's incredibly robust, even in comparison to the previous one. And as I said there, it's fully compatible with all those industry accepted ancillaries, particularly from Cetac. There are some other ones out there as well. So that is kind of it, really. It's a bit of a sort of headline tour, certainly from me, and there's a bit more detail from David. But yeah, thank you very much for your attention. I hope it's been useful. You've all got my contact details, so obviously happy to have conversations with people after this. But just to end that, we will see if there's any questions. Certainly, I say we've certainly seen one from Mark already, and unfortunately, Mark, I don't know the answer. But let's have a look what we've got on here. Okay, so I'm just going to stop sharing the screen so I can go back to the Q&A. My laptop's a little bit slow at times, so do excuse me. Okay, so just opening up the Q&A for you. Okay, so a couple of questions. Okay, so the first one, I'm going to absolutely dump this on David.
Thank you.
But I know he's done this before. So it's a question from Thomas, and basically the question, I don't know if you can see. Can you see the Q&A, David?
Yeah, I can see some.
So Thomas's question is the system capable of time-resolved analysis similar to an ICP-MS? If it is, what's the speed of the detector? Are there triggering capabilities to enable connections to things like IC or laser systems?
Yes, it's not particularly seamless. There is a time response mode. It is more designed as more sort of a tuning tool, perhaps, but we have been using this down with our colleagues at Manchester University for a chromatography solution. It was basically a small short column chromatography of uranium at quite high levels, and so you can cut it down. So obviously we're largely in the time resolve thing restricted to one element, really. From memory off the top of my head, and it was a while ago, I think we managed to cut the acquisition down to about 0.1, and you could export it just as a time versus uranium intensity plot. I would have to look up the exact figures because that was 2-3 years ago, but we did achieve a good, say, chromatographic kind of time resolve thing. I would have to refresh myself on the exact numbers and details.
Okay, all right. Well, let's say we'll come back to you on that, Thomas, anyway, but with a bit more information. But yeah, hopefully that answers your question. We have two questions from Dr. Rosen. The first one is, what does automatic sorting of absorption lines mean? In the current software, or the previous software, you could argue that a little bit of time was lost, just the moving of the various sort of monochromators, lenses, etc., as they shifted from one line to the other. It just slowed the whole thing down just a little bit. Whereas now the system just automatically sorts the best order in terms of axial and radial, which wavelengths. It just means it is just quicker. It just means that your run time is about 10% quicker. The system works out what the best lines to measure in terms of time saving. So it's just an automatic function within the software. And the second question was, has the software new instrument undergone significant changes compared to the previous OES model? I'm not sure what software version you're running. So the current one is Aspect 1.4. The previous one was 1.3.2. It could have been that you're running an earlier one than that. Easy thing to do is drop me an email. You've also got my contact details. If in case you have, it's matt.allen@scimed.co.uk. So contact me after this, and we can basically set up something that allows you to look at the new software, have a play with it, see what difference it is compared to whatever version it is that you're running at the moment. So I hope that answers your question. Mark, as I said, Mark, you've asked what total solids can a precision nebulizer work with. I'll have to be totally honest, off the top of my head, I'm not sure. So I'll look into that for you, Mark, and get back to you. And there's some other questions in the chat function, so just let me load that up. So bear with me just a second. Okay. Okay, there's a couple of questions from somebody. I shouldn't laugh. You mentioned recycled argon for the tail end of the plasma. Does the 11 litres per minute include the optimal purge? Yes, it does. And then the background's collected simultaneously in every element. What's the usual sample to sample runtime for tail elements? I would say about 2.5 minutes. It's going to be about 2.5 minutes to measure 10 elements, typically, would be the answer to that. And that pretty much covers it, I think. There's a couple more questions which are quite detailed, which I'll come back to at a later stage. But that, I believe, is it. Speak now or forever hold your peace if you've got any other questions to throw in there. I'm just going to check both the Q&A and the chat functions. So, okay, nothing else is appearing. Okay. Well, look, thank you very much for your time, everyone. There's a couple of the slides that David did. And there's we'd have to check which information we can send out, but there's nothing that's kind of sensitive, if you see what I mean, that's in there, confidential. But we'll basically try and put all these into a PDF and send people a copy of the slides. We will be in touch with all of you. As I most of you, I think you've all got my contact details. So if you have any questions, please do get in touch. I hope it's been useful for you. Thank you very much for your time, and come back to us if you need anything else. Thanks again. Take care.